Okay, dear student, let us see what is there in this question. The resistor R is connected in a circuit with a cell that has internal resistance, but that internal resistance is not shown here. It will be better if we show it, whether it is used in our answer or not. But anyways, we are showing it. The ammeter and the voltmeter are the ideal one. State what is meant by an ideal voltmeter. Okay, so what do you mean by the ideal voltmeter? So simple thing that the voltmeter, like the ideal voltmeter, is the one which has the infinite resistance, and here in the ammeter the resistance is zero. Okay, so the resistance is zero here, and this. Okay, now there is another question that usually students are confused with, like how do you see that yes, the ammeter is the ideal or the voltmeter is the ideal? How can we recognize that? So my dear students, whenever it is written like this, like they are drawn this ammeter like this and this, it is usually the ideal voltmeter only, and these ideal voltmeter, ideal ammeters are in our syllabus. Otherwise the other voltmeter, like we have done that, like in our course we were doing that, but in IB I have not seen those kind of questions. So we are always using ideal voltmeter and ideal ammeter. So ammeter is always placed in series with the resistance, voltmeter is always placed in parallel to the resistance, and the resistance of the voltmeter is infinite and the resistance of ammeter is zero. So ammeter, although it is attached along with the resistor R in series, it is not adding any resistance to the branch. So whether it is there or whether it is not there, it is not making any difference. Okay, it's just measuring the current there. And the voltmeter, because the resistance is infinite, so this branch is not going to have any current which is going to flow into it. So all of the current that is coming here, it goes here, and simply it goes to the ammeter, it crosses it over, and it goes like this. Okay, it goes like this, so it does not enter into this branch, but still the voltmeter is going to give you a reading, like what is the voltage difference across the resistance R, through which across which the voltmeter is attached. So this ammeter is going to give you the reading for the current which is passing through the resistor R, and this voltmeter is going to give you the value of the potential difference across the resistor through which the current is passing. But for the ammeter, the resistance will be taken as zero, and for the voltmeter, the resistance will be infinite. So the current in this branch will be zero. So these are a couple of things that you have to remember whenever we are working with the ideal ammeter or ideal voltmeter. So this is done, and I would be showing you the mark scheme also, and then we will see what is the answer given in the mark scheme in regards to A. Now the resistor of R is 50 ohm and the voltmeter reads 147. Calculate the current. Okay, so the resistor R is 50 ohm and the voltmeter reading is 1.47 volt. So this is 1.47 volt. So this ammeter is not having any resistor. So for this time you can even imagine that there is no ammeter. So the circuit will look somewhat like this. This is the resistor which is 50 ohm, and you have a voltmeter across it. That's it. Like this. So the voltmeter reading is given as 1.47, and this is this. Clearly, this voltmeter reading V is equal to IR, and I is the current which is passing through the resistor and R is the resistance. So according to me, the answer will be 1.47 is equal to 50 into the current. So the current I will be given by 1.47. And is there any milli or something anywhere? No, you have to find the current in milliamperes. Okay, this divided by 50. So we will find this value. Okay, I'm using my calculator now. And yeah, so the value is coming out to be 0.0294 amperes. And in milli, 1, 2, 3, it will be 29.4 milliampere. Yeah, this is the answer that we get for the first part, like 1A here. And now we are going to see the mark scheme. We will find the answer A and answer B one there, and we'll see if they are getting the same answer, 29.4. Okay, yes, this is the question number 5A. Yeah, so in the ideal voltmeter, The resistance is infinite and no current is flowing through it. And B1 is given by 1.47 divided by 50, and the current is coming out to be 29.4 milliampere, exactly the same value that we have calculated earlier. Let us now see what is the next question. Resistor capital R is replaced with another resistor which is 10 ohm. The ammeter now reads 139 milliampere. Show that the internal resistance of the cell is 0.7. Okay, so let me note down the values. The resistance now is 10 ohm, and the value of current which is noted is 139 milliampere. We have to find the internal resistance. Yeah, so this is the diagram, and we have to find the internal resistor here. Let us now think, let us imagine what is happening. This resistor is given as 10 ohm now, and the voltmeter reading, okay, voltmeter reading is not given, but we can find it, isn't it? The current is given, so the current passing through this is 139 milliampere. Accordingly, I can find this voltage, and the I voltmeter is the ideal voltmeter, so the current which is coming out of this, that will go like this, and it will enter into the ammeter, complete current, and the complete current will be returned back to the battery. It means that if I'm naming this point as X and this point as Y, so the voltage difference across X, Y, that is given by the voltmeter reading, that is V, and that will be equal to V is equal to IR, 139 milli into the resistance which is 10. So that will be the voltmeter reading here across XY, and that will be equal to the terminal potential difference across the battery. I hope you know what is terminal potential difference. So I have given so many questions for paper 1, and I have discussed terminal potential difference in complete in details. And also there is an online course I have uploaded, and there also I have talked about it. But still, I'm just going to give you the definition. Terminal potential difference across a battery is defined as the potential difference across the battery, like this point is A and this point is B. So potential difference across the point AB when current is passing through it. So current is not zero, and internal resistance is also not zero. That is called Vt. And this Vt is given by E minus IR. There are two types of things. One is charging and another is discharging. Two cases in regards to Vt. So in case of charging, it is this. In case of discharging, it is E minus IR. Discharging means that current is moving out like this, and charging means that the current is uh, charging the battery, so current is going into the battery. So if this kind of case is there, like in this case, definitely the current is withdrawn from the battery, so it is this kind of case which is known as discharging, and the terminal voltage difference will be given by E minus IR. So we are using E minus IR. This is the special case in which charging of the battery is taking place, but that is not the case in this question. I am just erasing it, and if you want to see this again, you can just go back to the video and you can watch it. Okay, so now Vt is given as E minus IR, but there are two variables now. One is E, it is not known, and the R is also not known, but I, we can just say that, okay, the same current is passing through the circuit. So the current is known to us, and Vt is equal to this. So Vt is known and current is known. So there are two variables and we are not able to solve this equation. We want to create a second equation to solve it. How can we do that? Okay, now what we do, for the same apparatus, another values is given in this. You see, this is what paper 2 questions do. Why are they difficult? Because they ask you one question in C part. Let us say the data is given in A. Okay, they would be asking you a question in A, and there are many questions. They're asking you a question in A or B, and the data is given in D. So this kind of I would say the misarrangements or that is done in these questions. So according to this data, now if the resistance is 50 and we have calculated the current. So current was coming out to be 29.4, by the way, I believe. uh, just a moment. Yes, 29.4. So I can use this value. So the voltage is given and the current is 29.4 milliampere. Vt is given as 1.47. So I have two equations now. Okay. So one equation will be this. Another equation will be 1.47 is equal to E minus 29.4 10 raised to power negative 3 is the current into R. Okay. And this value can also be substituted. So this, we have to calculate this value first of all. So this will be 10 raised to power negative 2, which will become 1.39. So 1.39 is equal to E minus, the current is taken to be 139 milli into the internal resistance R. So we will find the value of E in both of these cases. We can equate them to find the value of the resistance, or these are just two equations that have to be solved simultaneously, nothing else. And we will have the answer. So I can write the easiest method will be to find the E, like plus 0.139 R is equal to 1.47 plus 0.0294 R. From this equation, we are going to find the internal resistance of the battery. Okay. Indeed, this question is quite confusing. It is difficult, no doubt about that. And there is a high chance that I believe 90% of the students would be confused in this. They would not be able to solve this part. So, why is it so tricky? Because the data given in B2 is insufficient, and you have to see the whole question. You have to read the complete question. So it's my advice to the students that you can first completely read the question. You can see which data is given where. So they usually give all the data, but that is so spread out that we don't know where the data is given. And I usually tell this thing to my students in my private classes, that paper two questions are not about your hard disk, that how many formulas do you remember, but it is more about the RAM. Okay, if you understand the computer terminology, like how many memories, how many data, how many things, how much data you can keep here while you are solving the question. Okay, so after using this funny analogy here, but let us move to the next question. I believe this is what we are supposed to do here. And the internal resistance will come out to be equal to 0.7. You can use the calculator and find the answer. I will just show you the mark scheme if they have done the same thing. Well, I think they have done the same thing. Yeah, absolutely correct. 29.450 plus R, and this they have just taken common. So that is why it is not looking similar to the equation that I have written, but they have also done exactly the same thing. So they found the EMF here, they found the EMF here, they equated both of these. So this is it. Let us now move to the next question now. Calculate the EMF of the cell. So when you know the internal resistance, you can now substitute the value in that equation and you can find the EMF in a very easy method. No problem at all. So I will not be doing this. Now, one of the connecting wires is placed in a magnetic field. So here the question changes. In place of like 5.3, now we are moving into 5.4. One of the connecting wires is placed in a magnetic field. The direction of the current in the wire is shown. Explain by the reference to the charge carriers in the wire how the magnetic force in the wire arises, like why the magnetic force is arising in this. So there will be like two kind of an explanation. We have to see the mark scheme for this, by the way, because there are two explanations we can give. So I don't want to confuse you people. It will be better if we go directly to the answers. Charge carriers are moving in the magnetic field. There is a magnetic force. Okay, so directly they are saying this thing, that there are charge carriers which are going. We are not going into the detailed explanation that is usually given in your books. So we need not to go there. Just we can write it that there are charges which are moving. Current can be assumed to be the movement of the positive charges which are going in the same direction. And by the application of the formula QVB, clearly there is a force F which is acting on this. This creates a magnetic field that interacts. Okay, that interacts with the external magnetic field. Even like this explanation is also not required. This is kind of extra explanation. I will explain you, but I believe this is the correct answer that we should be giving. Well, this answer is well within our domain. You know this. Like I need not to explain you anything in this, and you already know that yes, this is the correct answer. That is why this is the best explanation. Now, this creates a magnetic field. Now what happens is there is one magnetic field which is created by the magnet, like from north to south, and there is a wire, and there is a magnetic field which is created by the current carrying conductor. For that, like also we use, like this thumb rule and the right hand palm rule type 1 I told you. So we create a magnetic field around it like this, and we say that the magnetic field is going like this. So this magnetic field and this magnetic field, they now interact with each other, and that is why there is force. They are now interacting with each other. So there is a change in the magnetic field line, the way the magnetic field was earlier present in the space. Now there is a different kind of a magnetic field in the space. That is why, due to the interaction of these two magnetic fields, there is force. But we need not to go into this explanation. I believe this is the best explanation that you have for yourself. Okay, because the question is why the wire is experiencing force, because there are charges which are moving in it, and there is a formula F is equal to QVB. Yes, let us now go for the next question. Identify the direction of the magnetic force on the wire. So what is the direction of the force here? So the formula for the force is BIL, and usually, like, there are many rules that you can use, but if you are following my YouTube channel, if you have seen all the paper 1 questions, I have clearly described you the right hand palm rule type 1, type 2 and all. So I would be using the right hand palm rule type 2. If we can use this, then you would be like able to understand what is happening. Now what is this? On your fingers you have the magnetic field. So magnetic field is going from north to south, so fingers will be downwards. And now the current is going into the right direction, so we have to go for this right direction, but in this way. So we can clearly imagine that the palm would be pointing into the page, so the force will be into the page. Okay, I'm writing it here. Fingers are placed on magnetic field. Thumb is placed on current. And the palm is pointing into the page. Yes, so the palm is pointing into the page, and that will give you the direction of the force. So this is the right hand palm rule type 2. So dear students, if you have problem in understanding this, you can use any rule, Fleming's right and left hand, whatever you want, or some other rule that your teacher is teaching you in the school might be. But these are the rules that I teach, and I feel like they are very, very useful. They're very easy. They are very highly understandable. And if you want to understand what is type 1, or you want to go into details, please refer to the paper 1 questions that are available, and I have given complete description there. So I will not be wasting time now, because these paper 2 questions are already taking a lot of time. Okay, so this is done. So the force will be into the page. Yes, into the plane of the paper. So that is the answer given here, and that's it. Now we would be moving to the next question. So this is it. So this is how we do this question. Okay, dear students, so I see you in the next video. All the best. Bye.